Imagine sending postcards to a friend on Mars, and suddenly, the replies stop. That's what NASA is facing with MAVEN, a robotic explorer orbiting Mars for over a decade. MAVEN's silence isn't just a technical glitch, it's a mystery that has scientists on edge. These lost signals are our only link to distant machines, carrying commands and precious data. MAVEN is crucial to understanding Mars and supporting our rovers on the surface. Now, NASA faces a race against time to solve the silence, sending messages into the void, hoping for a response. This is a stark reminder of the risks and challenges of space exploration. The loss of MAVEN is more than a missing machine. It's a gap in our quest to explore the unknown. As we look up at Mars, we're all waiting and listening for a sign from our distant friend. MAVEN stands for Mars Atmosphere and Volatile Evolution, a spacecraft sent to solve Mars's greatest mystery. Where did its air and water go? Billions of years ago, Mars was warm and wet. Now it's a cold desert with a thin atmosphere. MAVEN's mission: study the upper atmosphere and how the solar wind stripped it away. Launched in 2013, MAVEN has been orbiting Mars since 2014, using its instruments to analyze particles and fields. Its findings help us understand not just Mars, but how planets lose their ability to support life. MAVEN is also a vital communications relay, beaming data from rovers like Curiosity and Perseverance back to Earth. Without MAVEN, the flow of information from Mars slows dramatically. Its dual role as scientist and messenger makes it indispensable at the Red Planet. Trouble began quietly. On December 4, 2025, MAVEN sent a routine status update. Everything normal. It was preparing for a standard occultation, passing behind Mars from Earth's view. 2 days later, as MAVEN emerged, NASA's Deep Space Network listened for its signal, but the silence continued. No signal, no data. At first, controllers stayed calm, trying different frequencies and procedures. Hours turned into days. By December 8, concern turned to alarm. NASA declared a spacecraft emergency. On December 9th, the public learned MAVEN was lost in space. The news rippled through the space community. After a decade of service, MAVEN had vanished. Now, NASA faced the daunting task of diagnosing a silent spacecraft over 100 million kilometers away. The mystery of MAVEN's silence had begun. NASA's engineers are now cosmic detectives, piecing together what happened. One theory: MAVEN went into an uncontrolled spin, making it impossible to aim its antenna at Earth. Another: it triggered safe mode, shutting down most systems and switching to a weaker antenna. A power or orientation failure could have drained its batteries, silencing it completely. Or, after years in harsh space, a critical component may have simply failed. These scenarios aren't mutually exclusive, and with no new data, every possibility is on the table. NASA must craft the right commands and hope for a response from the void. MAVEN's silence is more than a scientific setback. It disrupts Mars exploration. Rovers like Perseverance and Curiosity rely on orbiters like MAVEN to relay their data home. With MAVEN offline, other orbiters must pick up the slack, straining resources and reducing data flow. The rovers can store data, but fewer communication windows mean less science reaches Earth. No immediate data is lost, but the network is now more fragile. If another orbiter fails, our rovers could be isolated. Each spacecraft is a vital link in a delicate chain. Losing MAVEN weakens our entire Martian presence. NASA hasn't given up. Engineers use the Deep Space Network's giant antennas to listen for any signal from MAVEN. Even a faint carrier wave would be a breakthrough. They're also sending blind commands, hoping MAVEN can hear and respond. Commands might reset its computer or reorient it toward Earth and the Sun. There's still hope. MAVEN could recover on its own, or its antenna might eventually point our way. Space history is full of miraculous recoveries. Whatever happens, MAVEN's decade of discoveries has transformed our understanding of Mars. Its data will guide future missions for years to come. This challenge pushes engineers to build even more resilient spacecraft. For now, we wait, listen, and hope for one more message from our atmospheric detective.